So let's just do 2 practice problems just so you can see other types of wording and other types of compounding periods for this topic. So the next question says you have $2,000 to put in a savings account with a 2% annual interest rate. It is compounded quarterly. How much money will you have after a year? Okay, so as soon as this interest rate is compounded for a different amount of time, we know we're going to be using this compound interest formula. Okay, so we are looking for what we have at the end of the year. So that's A. My principal, or the initial amount that I invest, is the $2,000. And I have 1 plus my interest rate is 0.02. Compounded quarterly. So quarterly, think of 4 quarters, has n equal to 4. So I will divide that interest rate by 4, but also multiply my exponent by 4 as well. And now for this equation, the one thing you should know is, since this interest rate is annually, t will always be in years. Okay, so we want to know how much money you'll have after a year. That is 1 in my exponent. I plug all of this in. Again, I suggest using fraction keys and parentheses. You should get 20, 40, and 30 cents. Okay, so that $2,000 made $40.30 for you just sitting in an account. Okay, that's the benefit of interest. Making your money make money for you. Okay, let's try one more. If at the end of 2 years, a savings account has a balance of $1,172.60, and the annual interest rate is compounded semi-annually at 3.2%, then what was the original amount deposited 2 years ago? So what is the question asking us for? The original amount, I'm going to change my color pen, is my principal. Okay, it's that initial value. It's my P. So that's what we will be solving for. Now we see that it's an annual interest rate compounded at a different time period. So that means we are using this formula. Now, we know we're going to be solving for P. So this value is what we had at the end of 2 years. So A is being replaced with that value. P we're trying to figure out. 1 plus my interest rate, which is 0.032. And now we're looking at semi-annually. That happens twice a year. Okay, so that means my n is going to be equal to 2. So we put in the 2 in the denominator, the n, a 2 in our exponent. And what is my time period? Well, this money has sat in this account for 2 years, so my exponent is 2. Now, just to make our lives a little bit simpler, I'm going to simplify this whole expression here to just one number with one exponent. So 1 plus 0.032 over 2 is equal to 1.016, all raised to the 4th power. So to solve for P, I'm going to divide by that 1.016 to the 4th power. And that's a 4th exponent. And I should get 1100.46 as my principal. So that means originally I invested about, exactly $1,100.46. And in 2 years, it grew to $1,172.60. So almost about $72 it increased.